Hi again, everyone, and welcome to the Mat 211 review of random variables, discrete and continuous. So we have this histogram, and the histogram to the left models the probability distribution of an event. So we don't know what event it is, but it's just some event. We want to determine the probability of the following: that x, our event, is between 1 and 3, that x is between 2 and 2.5, and that x is at most 4. So let's address each of these separately. Let's start with A here, that x is between 1 and 3. So now if we look at our histogram, we want the probability that we're between 1 and 3. So that means that we have the probability here of between 1 and 2, which we know is 0.1, and then the probability between 2 and 3 we know to be 0.4. So what we need to do in order to get to the probability of being between 1 and 3 is to sum these two probabilities up. So let's go ahead and do that. And we'll erase our scribbles all of this. So we have that the probability that x is between 1 and 3, which is the same thing as saying that x is greater than 1 and less than 3, that's going to be equal to the probability that x is between 1 and 2 plus the probability that x is between 2 and 3, which is equal to 0.1, as we said, plus 0.4 from here, and that equals 0.5. So there we go, we finished A. Probability of 1 less than x less than 3 is equal to 0.5. So now we can move on to part B, that x is between 2 and 2.5. I'm going to go ahead and erase this for right now. So we're looking for the probability that x is between 2 and 2.5. Now notice that on our histogram here, we don't have a 2.5. 2.5 is in here. So we don't have that clearly demarked on here, but we can, assuming that the probability is evenly distributed in here, we can go ahead and solve for this by using a little bit of geometry. So if we just look at this, just this bar here, and we have that this is the width from 2 to 3. So this equals 1, this width here. Now if we split that in half so that we get to 2.5, then we know that this width is going to be 0.5. Now, because this is a histogram, the vertical value, this direction, is going to equal the value of the probability, and we can see that if we look, just draw a line over to our y-axis here. So this is going to be 0.4. So what we're looking for is the area of this split part of our rectangle here. So that means we are looking for the area of 0.5, so half of our full width of our bar here, times our 0.4, which equals 0.2. Then because this histogram is already representing the probability, we know that the probability of being from 2, of x being from 2 to 2.5 is equal to this 0.2, which is this area here. So there we go. We've got part B done. So we'll write that up here as well. Probability of being between 2 and 2.5 is equal to 0.2. So lastly, let's erase that and we'll do our last part here. Come on, eraser. There we go. So our last part C is that x is at most 4. So what this means is that we can include everything, all of these numbers, as long as they're no greater than 4, because we're at most 4. So anything less than that is also true. So we can write this as the probability that x is less than or equal to 4. Now this includes the probability of being between 0 and 1. And then we're going to add to that the probability of being between 1 and 2. Plus the probability of being between 2 and 3. And then plus the probability of being between 3 and 4. Since x can go all the way up to 4. And then we will, of course, omit this probability because that's larger. So then all we need to do is substitute in our known values here. So the probability of being between 0 and 1 is 2, or 0.2, excuse me, 0.2. Then the probability of being between 1 and 2 is 0.1. The probability of being between 2 and 3 is 0.4, so plus 0.4. And then the probability of being between 3 and 4 is 0.2. 0.2. If we sum these up, this equals 0.9. Now this makes sense because our whole probability distribution here from 0 all the way up to 5 has to equal 1. And we noticed that the only probability that we excluded here was this probability of being between 4 and 5, which equals 0.1. So if you notice, 1 minus 0.9 equals 0.1. So we know that we've done this correctly. So therefore, the probability that x is less than or equal to 4 is equal to 0.9. And these are our answer. So before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for tutoring services for your specific course, you can go to the Tutor Search tool, which you can find on our main website page here, or by going directly to the tool at this full link here, and that will allow you to search for tutoring services for your specific course. So thanks so much, and have a great rest of your day.